All right, so hello and welcome to this tutorial on looking at interaction networks, particularly mention networks on Twitter. So what I'm going to do is basically just talk you through a couple of steps um, that one can perform in order to get a better understanding of the kind of interaction space that evolves around particular topics as captured with our Twitter capture and analysis toolkit, which you can see here on the screen. Here on the top, you can select data sets. Then you have a series of possibilities to create sub-selections from those data sets, in particular using date parameters, but also querying for particular words, excluding particular words, focusing on individual users, or even searching in the URLs that have been shared by Twitter users. So simply start right off with this global warming data set here. It's going onto 18 million tweets. So that's really big. If you want to look at the full data set in terms of mentions, that's definitely gonna be a pretty big file and a lot of users. We can actually see that even on the 2 days that are currently selected, 44,000 users participated in that data set. If I look at that data set over the whole period, I'd probably get into the millions of users. Also because this is quite a wide data set. If you look here at the queries, we've been querying global warming with space, global warming without, and then obviously a very general term, which is climate, right? Which indeed appears in many different contexts. Um, so I'm not going to dwell on this here for too long. Um, but obviously, the first thing to do when looking at a particular data set is to look a little bit at just at the basics. How many tweets contain links? That very often is kind of a first indicator to kind of better understand what kind of conversation, or at least kind of what kind of expression space is built around the queries that were captured. Here I can also look a little bit at the temporal variations. But in this video, I don't want to focus on that, but I want to go directly into a particular kind of output that is definitely very interesting. Also, look at Bruns and Burgess paper on the topic that introduces a little bit to the notion of social interaction, and in particular the mapping and exploration of these kinds of interactions. So what I'm going to do is I've already scrolled down here to the network section, and I'm going to focus on this first kind of export, which is basically based on mentions between users. And what's interesting about that is that a mention is of course something that goes from one user to the other. So there is a source and a target, and that means that what we get is a directed graph, which is going to be important later on. What's also interesting maybe is that this output indeed has variable tie strength. That means if a node mentions another one not only once but a couple of times, the strength between those nodes gets stronger, and this is something we'll be when analyzing. So what I'm going to do here is quite simple. I'm gonna launch that output, and the script asks me here how many users I want to include. So what's important to know here is that this is kind of a filter that happens on the level of TCAT itself. And that means that you kind of generate a file that is much smaller than the full mention network would actually be. And this allows you, particularly with, if you don't have a very strong machine, if you don't have a lot of RAM, this allows you to work with Gephi and work in a way that is not too slow and not too cumbersome, and maybe still get kind of the major interactions in that data set. The cutoff is basically based on the number of received mentions, right? So if we here, for example, choose 500, what we're going to get are the 500 users that have received the most mentions in that data set. You'd be probably fine on most machines to go up till 5,000. On machines that are a little bit stronger, have more than 4 gigabytes of RAM, 64-bit machines, you could probably still do easily 50,000, 100,000. If you go higher, it's going to get really slow, and it's going to also be quite a challenge to really get something very readable out of it in terms of specialization and so forth. So I'm basically just going to stick with the 500 here and going to use that in this tutorial. You can of course apply the same steps to larger networks. Okay, let's get going here. This is quite fast still, so that's nice. Well, what you see here is that the tool indeed generated a file, and important, you can also see that it added the 500 user cutoff into the file name. It also has all of the date information here, and I'm just gonna save that on my desktop here. All right, and then I'm gonna write off move. Whoops, I haven't even started it. Gonna move over to Gephi, which is the tool I'm going to use to analyze and spatialize that kind of data. So what you've seen in my case here, when Gephi started up, it went right into the data laboratory. Normally it opens in the overview, and this is also this first panel that I'm going to focus on. So just to give you a bit of an idea, right, Gephi is organized around those three panels: overview, data laboratory, and preview, and they're really quite specific in terms of what you do there. Overview is basically the interactive graph exploration elements that Gephi provides. Data laboratory is a bit of a kind of an Excel view on the data, so you can look at all of the nodes and all of the connections in kind of a table perspective, and that can be really nice filtering for just reading the data instead of staring at a graph. And then the preview, the last one here, that is basically just a panel that allows you to export versions of your graph that look a bit nicer than basically the kind of graph that Gephi draws here in this panel in the middle. All right, so I'm gonna open. I'm gonna go ahead to my desktop, get my global warming data set here, and indeed you can see. First of all, that I got 500 nodes, and I also I can already see that there are 1,000 or nearly 1,000 connections here between those nodes, which ultimately isn't that little if you consider that we're only talking about 2 days of data here, right? So if you take a longer duration, you can expect, in many cases, to get quite a dense network out of this. And this is actually kind of, in a sense, already a first finding, right? Just looking at kind of the number of nodes and then noticing the number of edges, I can already tell you that this is not a kind of a super connected kind of network, right? You may stumble over cases where 500 nodes produce thousands of connections, right? So this is already quite interesting. What's important here, man, you can kind of safely ignore those pieces here on the those options here on the side. What is really important is what I said before. It's a mentioned network. That means it's a directed network, and this needs to be specified, right? If not, if you don't specify that, or if you select undirected, then Gephi will treat it differently and will lose some of the information that exists in that graph, right? So mentioned network equals directed network, and that is good. Okay, so I'm going to import that data. And well, to just give you a bit of an idea, right? So this overview view of Gephi has yeah, kind of a number of panels. You can kind of switch those panels around, right? They're draggable. You can close them. You can sort them differently. What's very important to know is if you close something by error, you can always get it back by selecting the particular panel from the window menu item up here. So here at the very right, we get a little bit of yeah, kind of a summary of what our graph is like, and that can be interesting. Then if we filter, right? So if we start filtering stuff, we're going to see here at the top right what kind of effects our filtering has. Yeah, so this is kind of yeah, a little bit of an info panel. The most important panels for what we're going to do today is obviously the graph itself, which allows us to already kind of investigate the network a little bit. But then what's kind of very important for today is going to be the ranking panel here. So I'm already kind of switching over there. We're going to use the ranking panel to basically color and size our nodes to express or to encode particular variables that are attached to the nodes, right? So this allows us to introduce some variation and differences in terms of node size and color, right? And those differences are going to allow us to get a bit of an idea what's actually happening in our data set, and what are the most mentioned accounts, what are the patterns that emerge, and so forth. So the ranking panel, that's going to be really important, and the layout panel is also going to be really important, right? So I'm going to just start right off saying I want to have my graph to look a little bit nicer, right? Here you can't see all that much. This is basically just a random positioning of the nodes on the screen, and while we see already kind of some more some thicker edges appearing here, that it's really quite unstructured. So what I'm going to do is I'm going to use a layout algorithm to basically use the structure of the graph, and by structure I mean just the kind of shape or the kind of distribution that exists in terms of mentions between users, and I'm going to use that structure to come to a more readable image. So here you've got kind of quite a number of different algorithms that you can use. Some are kind of really basic, like you can rotate the graph, and you can adjust the labels. That's also a kind of a quite useful thing. But what we have here is also a series of simulations that actually very often based on physics simulation that allow us to get to indeed that kind of layout that allows us to read the graph much better. I'm gonna use Force Atlas 2. It's probably the most general purpose algorithm inside of that selection. It's quite fast, also because it's multi-threaded. It allows for a number of optional parameters, so it's really quite flexible. What in general you have to expect when working with something like this is you'll have to wiggle around a bit, right? So this is not something where you can say you always need this parameter and this gives you the best results. depending on the size of the network, depending on the structure of the network, you may have to do quite a number of adjustments to get to something that is convenient. So what I'm going to do is I'm not gonna. I'm actually gonna make it a bit bigger here so we see that. Yeah, so we get all the options. So what I'm going to do is I'm not going to bother right now with the parameters. I'm just going to run it first, and then I'm gonna think about how I can adapt things a little bit more. So what we see, and that's kind of quite interesting. I'm going to stop it before things weed out. So we can already see kind of a number of things. First, we see this kind of connected area emerge here in the middle, right? And that is kind of in graph theory, it's called a giant component, right? It's a part of the network that is connected, and it's quite big here. And that means this is yeah. Is this a conversation? Well, maybe it's a kind of a network conversation, right? It's not that everybody's talking to everybody, but there is some kind of circularity. So that's kind of the first thing. The second thing is that then there are quite a number of nodes around here that that float alone. How can they float alone if those are the most mentioned users? It's simply that if you select the top 500, well, what you get is indeed the most mentioned nodes, but what is left out, of course, are all of the mentioning nodes, right? That maybe didn't receive any mentions themselves, so they are not here, right? What's also interesting is this thing here on the side, and we've got kind of several of those kind of side conversations, and here you can already see, right? There's really quite something going on here between that node doing a lot of mentions on that node. Right, we'll have to work on that a little bit more to make it readable. So the first thing that I'm going to do here is going to leave it run a bit, and what you see is that a lot of those nodes here, they continue to flow away from our giant component, and our giant component is also kind of really not very readable, like a lot of overlaps here. So what I'm going to do is, first of all, I'm going to click here on the left on prevent overlap, well, which already spaces things out a little bit, but the problem is that the graph is simply too tight for the prevent overlap to do its magic here. So I'm going to take it away again. What I'm going to do is I'm going to introduce a bit more scale into the graph. So here you got this scaling parameter. I'm going to move that up to 10. And you can already see, right, that spaces our network a lot more. And things are becoming a bit more readable. The problem is that all of those other nodes here on the side, they continue moving away. And I don't necessarily want that, right? Because indeed, very often I'm only interested in that giant component here, and I'm not so interested in what's happening around here. But here are some kind of interesting cases, and I don't want to lose them. So what I'm going to do is I'm going to center that here again. I'm gonna put a bit more gravity in here, and gravity is this force that drags everything to the center. I'm just gonna go right out and I just put that to 100, bomb, and what you're gonna see is everything's everything's coming really fast. Everything's coming back to the middle again. And here obviously I went a bit too far, right? So I'm gonna adjust that maybe to 20. Okay, and here you can now see that I'm starting to get a little bit of a compromise between what we've had before, right? So those kind of external nodes are no longer floating. They are still floating a little bit, but they are staying, well, quite put now. So using scaling and gravity, you get that kind of effect, right? And now I can click at prevent overlap, and indeed I get something that is more spaced out, and I'm starting to see a little bit of a structure, right? There seems to be a sub-conversation here, and then kind of this denser cluster here in the middle. So I'm going to zoom out again, and that layout is already quite okay, I'd say, at least for starters. So what I'm going to do next, so I stop the algorithm here again. That's maybe something to add here, right? Very often those algorithms, they don't stop, right? And those are physics simulation. So if they don't find the perfect equilibrium, and that's rare in a big graph, they're just going to continue to wiggle around. And if you have particularly big graphs, it may even happen sometimes that after minutes or even hours of running an algorithm, quite some changes still appear, but generally the algorithm stabilizes, and you can kind of see that in the sense that right, if I keep it running here, not much is happening. If I zoom in really far, I may still see some movement, some tiny movement, but the thing has basically stabilized. So all right, what I'm going to do next is now I've got a bit of structure here. Now I want to see. So quite simply, I want to be able to identify the most mentioned accounts, and I'm going to use size to indicate that. So I'm going to go here to this left panel, the ranking panel, and I'm going to select here the diamond, which is basically just the logo for sizing nodes, right? So I've selected nodes here, the diamond, and here I can now ask for a number of, or I can use a number of variables that are in this data set. So I'm just going to quickly explain what they mean. Degree in general means quite simply the number of nodes another node is connected to. That doesn't include the weight of the links, right? So it's simply, right, if one node is connected to 3 other nodes, then it's a degree. Then its degree is 3. Because this is a directed graph, this can go into 2 directions, right? Degree, so that's kind of the number of mentions that one received, that a node received, and then out degree, and that's kind of the number of mentions that a node makes, right? So you can think of that in terms of kind of incoming links and outgoing links. So in degree encodes, in that sense, the number of mentions, or actually in this case, it's the number of other nodes that have mentioned a particular account. What's important to know is here that because we didn't take into account the full data set, but only have the last 500 here, in degree here actually only concerns the visible nodes, right? And not all of the other nodes that, all of the other 40,000 users that were also in our data set here. Fortunately, we still have that information because Eric and I, we put that into the file. So you can actually use number of mentions here as an indicator or as the variable that encodes how often all of these accounts have been mentioned in the full 2-day data set and not just in the top 500. So I've selected number of mentions, right, because that's what I'm interested in. And here you can select then the minimum number of the minimum size, and also here the maximum size. That's again kind of really relative, right? So I'm going to just apply it. And what you can see is that probably at the beginning, most of the nodes were sized, let's say, at 10. So some of the nodes here have become much bigger, and some have become smaller. Right? This is not something where you can say there's this one best way to do it. It's rather like, again, a bit of wiggling, and I think it's really small here, so I'm gonna make the smallest ones a little bit bigger. All right, so well, that's a bit too big for my taste. So you can see, right? I'm indeed already wiggling. So that's kind of interesting. So what you see is that indeed we've got those 2 accounts here who are highly mentioned. You can also see that because I've resized the nodes, they again overlap a little bit here. So what I can do is simply run the algorithm, the layout algorithm, really quickly again yeah, and it will take again, now it will take into account the new node sizes. Right, I'm already seeing something that's kind of interesting. So what I'm noticing is indeed that those two nodes have been mentioned a lot, right? And there are kind of now several ways of kind of dealing with that, and kind of saying, all right, so I wanna know more about those nodes. I can zoom in a little bit, and I can, for example, go at the bottom and click on the T, and then show the node labels. Well, here you can't see much. I have to make the font a little bit smaller here on the right. And okay. All right, so now I'm able to kind of read things here a little bit better, and I can see, okay, there's this one account, the Earth Network, and this other account, John Luden, who are indeed in our data set, right? In those 2 days, the most mentioned ones. It's also nice if you hover here over a node, you can now see which nodes mention this one, or which those nodes are mentioned by this one. So you can see actually the Earth Network here. You can see that that arrow down here to Tom Burke, right? So it's not only that the Earth Network has received a lot of mentions, it has also a lot of outgoing mentions, right? So that is definitely interesting. All right, so what I'm going to do is I am going to again put the labels away because they make the whole thing quite a bit slower. And I just want to quickly show you the data laboratory view, because this is also kind of just a way of getting little bit of a view of the data, right? So instead of looking at that stuff in the graph view, I could have simply said, all right, I sort my data set by number of mentions, and then, well, this is basically, you know, it from Excel, kind of a table view on the data, and already here, right, I see the Earth Network, John Luden, exactly the two accounts that I've seen before. So one can actually do quite a lot of things here in the data laboratory, and I must admit I've been spending more and more time doing things here because in particularly in bigger networks, right, the graph can quickly become quite unreadable. So now that is interesting. So, whoops, sorry. The next thing I want to show you is something that is quite interesting, and that is the possibility of encoding not one but two variables on the nodes, right? So here already I've used size to give an indication of how many mentions a node has received, and now I'm going to actually look at color to get a similar kind of possibility to visualize another variable. As you've seen, I sometimes have to wiggle around here also with the panel sizes, right? So if you've got a big screen, that's really great for this kind of work. But for this video tutorial, of course, I had to do something a little bit. So before we used the diamond here for sizing nodes. Now I'm going to switch on to color. I really like using a heat scale. There are some pre-configured color scales that you can look up here. I really like the heat going from kind of a light blue or a bluish. It goes a bit through the green here. It goes yellow and red. So what I basically do to get that is I set three colors. I set blue here, right? So you can set colors. So I can make it a little bit bluer, blue here, then yellow in the middle and red at the end, and then a Gephi will simply kind of generate what's in between. So here I can still use the number of mentions for color as well. And that's really can also be really nice to actually simply use color and size as indicators. Really helps with reading. But what you also see kind of really quickly here is that the difference is really quite big. So the difference between the most mentioned and the not so often mentioned accounts is really kind of big, and you can see that really well in the data laboratory, right? That we got those two nodes that received 700 or well over 700 mentions here, and then kind of the third one is already only at 94. If I want to find that node in the overview, that can be very difficult, right? So where is that? That third node? Everything's kind of already bluish here because the difference is so big. I can do two things. So first of all, I can adapt my coloring a little bit to that kind of big gap, and I can click here on spline. And instead of just using a linear axis to color stuff, I can say I use it like this. Yeah, and you can see by adapting that curve, I'm able to introduce kind of more difference or more differentiation into those lower ranks of nodes. So I also see that kind of that there's a difference between this node and this node, which before wasn't so visible, and that is of course very interesting. So that may be quite useful. If I want to find a specific node, what I can also do is go back to the data laboratory. Every time it changes, it flips back into, it doesn't remember how I sorted it. That can be annoying. So if I want to find that node here, I click right on the node, and Mac users, right? If I highly recommend getting a good right-clicking scheme configured, because you're needing a lot of right-clicking with Gephi. I can simply say select an overview, and then what it will do, it will zoom here on that node, climate things, right? And that is indeed kind of part of that kind of strong network, right? Here's kind of a sub-conversation. So that's definitely interesting, right? So one of the things that one could then start to do is actually, well, try and about those top nodes, right? And that can be very interesting. But what I want to do is not actually use the same variable for coloring, but first of all, I'm going to go back to linear. I want to encode another thing, right? And I want to see. So currently, the number of mention gives me the most, maybe prominent, influential. I don't know, but definitely the most mentioned users. But I can encode now a second variable here. I'm going to change it to number of tweets, which is simply so how many tweets have those users written. Wow, and what is kind of really interesting here is that that there is definitely a correlation between the number of tweets that those accounts have sent and the number of mentions they have received, right? That's kind of astounding that there's really such good correlation. Let's look here in the data laboratory, just be sure everything's going fine here. Yeah, so they have also kind of sent quite a number of tweets, and you can actually see that there is a lot of overlap here between received mentions and sent tweets. In many data sets, this is not at all the case. So I'm a bit surprised actually. Well, here's a bit of a difference, right? So this account, for example, has more tweets than it has received mentions. But very often, what you find is indeed accounts that just tweet very little, right, and therefore also get mentioned not that much. So this is a bit of an outlier, but still it's not that important for this demonstration. What's important is that indeed, in many cases, you can see that kind of contrast, right? So you see kind of the most active nodes by number of tweets, and then kind of the most they kind of get the most attention, right, by looking at the number of mentions, right? Yeah, so that's kind of interesting here. And well, kind of the last thing I want to show you before moving into the export is you can also kind of generate new variables from the data you already have. And this happens largely in this statistics panel here on the right, where I can use a couple of algorithms. You may know some of them, right? You know PageRank, for example. I can use a couple of algorithms to kind of derive information from the structure of the network, right? So you all know that the PageRank has to do with, on the one side, the number, but more importantly, the structure of linking in a network, right? And PageRank indeed kind of transforms a structure like this into a value. So I could, for example, say, all right, let's run up, and I'm running it. And what I'm going to get actually as a result, we can see that in the data laboratory, is now for every node, I'm also gonna have this new column, right? And I am seeing that this column has been added, and there are values that have been added. And what is kind of very interesting is that the nodes here that have very high page rank are not necessarily the ones I'm sorry, that have received the largest number of mentions. I'm just going to put the labels away again. When I click here on the left to my variable selection, PageRank has been added. Up. And wow, okay, so now I get something that's really interesting. So on the one side, those are the most mentioned nodes, but they are not necessarily mentioned by other very influential nodes. So they seem to get mentioned by a lot of the smaller accounts. I'm sorry. Whereas actually this node here has received fewer mentions, but apparently mentions from kind of topologically interesting areas of the network, right? So PageRank can sometimes, well, it's sometimes introduced as an authority measure, and it can sometimes lead to those quite surprising results, right? So, well, sometimes PageRank is described as this algorithm that has to do with yeah, you could say getting attention from other nodes or well, web pages or whatever that already receive a lot of attention, right? And that indeed means that yeah, it's a kind of an interesting result, because it's not purely quantitative in a sense that it's just counting in links, but it's really taken into account the whole structure of the graph. So this seems to be quite an important node, right? It receives mentions from interesting sections of the network, and we can again kind of look at it and then see, okay, climate reality. What kind of account is that, right? So the last algorithm I want to show you here is called Betweenness centrality, and it's actually not directly identified here. You have to run the network diameter thing here. It's directed graph, right? And that actually generates a whole number of variables. So if I go back again into the data laboratory, I can see it has actually added 3 new columns: eccentricity, closeness, centrality, and betweenness centrality. I'm not going to go into eccentricity and closeness. I'm going to talk quickly about the betweenness centrality. Betweenness centrality is often being discussed as in terms of social capital and in relation with bridging capital, right? So when we talk about social capital, the idea is that there are kind of two types. It's a concept that was introduced already quite some time ago, and it basically refers to this idea that nodes may play a role in keeping a dense, or they may play a role in making a kind of a cluster or a group dense, right? So that is called bonding, right? Bonding, yeah, is kind of this local capacity of making a group denser, right? Making a clique tighter. And the second thing is bridging, right? And this is this idea that some nodes, indeed, because they're strategically positioned, are able to bridge between subcommunities. And what I expect here actually to happen if I use that value is that some of the nodes who sit here, right, between those communities, right? If we say that this is kind of a tight one here in the middle, and then this and up here, right? We got or down here, we got those sub-communities. What I expect to get from Betweenness Centrality is going to indicate those nodes that are kind of responsible for keeping all of this together, right? So I'm just going to select it here, Betweenness Centrality, and again, just apply it. And indeed, right? So what happened is that some of the kind of, you can also think about them as brokers, right? And you can see, right? So this one, for example, points quite far into that direction. It also points to this kind of subnetwork here, right? And it points to this subnetwork here, and this is why it has high betweenness. This one also has high betweenness, right? These two, because they connect that one here, yeah, this one here and this one here, right? So those are also interesting, right? Because they're kind of nodes that are responsible, for pushing information or for receiving information from different areas of the larger network, right? So I find Betweenness Centrality very often very interesting, and again we can look here at that account, right? Climate thanks, and that may indeed be very often bridging accounts. So accounts with high Betweenness Centrality are accounts that are really kind of active, right? They get mentioned, they mention, and they're not just in their own peer group, right? But they are really kind of very often subject matter experts or activists, right? That are really engaged in information sharing, and that's why indeed they are kind of connected to different points in the topology. So the last thing I want to show you, and then I'm going to stop this video, is how to export that in a kind of visually a little bit more. It's not so ugly here, but still. So the first thing I'm going to do actually is I'm gonna here's a lot of overlap between the labels, and I don't like that, so I'm gonna run an algorithm that helps me with that a little bit. And it's here on the left side, and it's called label adjust. And what it does, it simply, I'm just gonna run it. Right, you see, it simply spaces the node out a little bit so that the labels overlap a bit less, right? So it doesn't change that much, but it just makes the whole thing much more readable. So we could have actually done that earlier. And then I'm going to move into preview here. And I'm gonna make my thing look a bit nicer, right? So I'm just gonna click refresh, and already you can see things look a bit nicer here. And in particular, what I find very, very useful is those curved connections. Actually, the curves are not simply aesthetic, but they encode direction. So if we look at this node here, right, because the curve is kind of bending clockwise, I know that this line here means this node is mentioning that node, right? So what you will find in many cases is actually two connections, right? So, oops, that's a bit too far. So for example, here, I see that this node here is mentioning that one more often than this one here is mentioning that one, right? And so you can really see that kind of relationship, right? So this is mentioning here, right? Clockwise, and this mentioning there. So that can be very useful. What I like to do a lot is to enhance readability by actually, you see every node actually here still has this black thing. And if I want to use a black font for my node labels, I get more readability if I put that black circle away, and I'm going to do that actually here on the left. Sorry, I kind of jumped a little bit over that, but this the preview panel is basically just a panel to get a bit of a nicer view of your graph, right? So all of those things here are just purely aesthetic, right? You can't move anything around here. It's simply a question of making things a little bit nicer. So here on the top, I got the nodes elements and border color. I'm going to just change the border color to parent. That means it's going to have just the same color as the rest, right? Yeah, in terms of readability, I lose a little bit of the contrast here. But I can get some of that back by doing something I also like to do a lot now. And that is going to the edges and making them a little bit transparent. Gonna give them an opacity of 70, right? 70%. And you're gonna see actually, well, I'm gonna go even lower. Yeah, you see they become, they're still readable, but they become a little bit lighter. Looks very nice. And now the last thing I'm gonna do is I'm gonna add the text label, and here you got the show. You can do a lot of stuff with that, right? You can the labels. Proportional size means that Gephi will simply give bigger fonts to bigger nodes. Reload it. Okay, and this is what I get, right? Here the difference indeed has been quite big. Remember, those two, in terms of size, and that's what I'm still coding here, those two nodes have indeed been, wow, yeah, really, really the most mentioned. So they're really, really big. I can make this a bit more readable by smaller font size. Yeah, and this is starting to look nice. I could then go back into the overview panel and wiggle around some more to make it more readable, maybe space it out a bit more. But already we got something that looks a bit nicer and is definitely still readable. I'd still probably go for a slightly smaller font. I'll go 6. Yeah, that's pretty nice. I like that. And then what I'm going to do is I'm going to export that, and I could export it either as a PDF, and I always recommend exporting it first as a PDF because a PDF you can still it's a vector format, right? So you can open it in Photoshop and then render it in any kind of size. But you can also export it as an SVG, which you can open in Illustrator. But PDF and SVG are very similar, or just as an image file, as a PNG. So I'm not gonna do that now. I'm just gonna say again, right? So what we've been looking at here is a mention network, and I've just showed you a couple of steps that one can take to be able to explore that a little bit, right? And here indeed I get kind of the most mentioned accounts, the kind of superstars here, and then I also get that kind of broker account, and that indeed allows me to start saying something about that network. And well, what you would do very often, what I do very often, is I create quite a number of images, and I keep the sizes the same. And then I just change the color to kind of different variables, and then you can kind of easily compare, right? So if you've got images, you export them, you can see them side by side or flip through them, and you can kind of compare, right? So if I say, right here, I'm kind of color encodes Betweenness centrality, that is nice. But I could, of course, keep PageRank, and then the climate reality account down here would become very visible, and then you could flip through it and see that kind of correlation or change between those elements. All right, so this is Gephi. It's in the beginning a little bit daunting, but honestly, it's not that difficult to use. It requires a bit of but you've already seen quite a number of things. So I would recommend working through some of those steps. And good luck, and I hope you have fun.